Right, so students, the last chapter for our AS statistics is the normal distribution. Okay, so for SPM students, you may learn it before, just that now for A level, you need to know how to use another new set of the distribution table. Okay, I will explain the difference between SPM table and also the A level table that we are using now later lah. Right. Okay, so let's have a look. What are we going to learn? So generally, we are going to learn everything about the normal distribution in this chapter lah, like how you apply use the table to find the probability lah, and so on. Okay. Okay, so again here, I think you should take on this. Normal distribution is actually a continuous random variable. All right, so a very, very simple summary, I would like to do it here. Okay, when we are having the random variables, right, generally we are having two types. You learned it before in chapter 4. So the first type is discrete random variable. Okay, then another one is continuous random variable. Actually, you see all this word before in chapter 1. Right, so under the discrete part, we are having two special discrete, right? We are having binomial and we are having geometric distribution. Okay, then for continuous, it's actually the special continuous random variable is actually the normal distribution. Okay, so this is what we have learned currently until now. Alright, so this is a very basic things that you should know. Binomial and geometric belongs to discrete, and then for normal, it belongs to continuous. Alright, okay, so let's have a look for the basic concept first. Alright, so what is continuous random variable? So continuous random variable cannot take precise value, but can only be given within a specific interval. Alright, and then usually for continuous random variable, usually the common one that we see is like time that taken to solve something or what, and then the mass, the weight, or the length. All these belongs to continuous random variable. Okay, so a continuous random variable x is defined by probability density function. It has a function. Alright, but usually the function can be quite complicated one. It depends what kind of function are you having, but it can be quite complicated sometimes. Okay, so together with the value between the function is valid, for example, a to b. Okay, so the area under the graph of y equals to fx represent the probability. So you need to take note of this. Area under the graph is actually the probability in statistics. Okay, so that means if let's say I'm having a function like this, okay, in the figure I'm having a function like this. If I integrate this function from x1 until x2, when I do the integration, the value that we get is the area under the graph, right? So this area under the graph also means that it is the probability x between x1 until x2. Okay, so this is the probability for x1 until x2. Yeah, right. So you have to try to link the area under the graph with the probability. Okay, therefore, when you want to integrate from x1 until x1, integrate from x1 until x1, you only get a 0. So there's no area. Okay, so therefore, when x1, x equals to x1, it is always equal to 0. So for continuous random variable, you need to highlight this one. Because when you want to get the probability for x equals to a particular value, it is undefined. You cannot get any area, so it is 0. It can be shown by using this concept here, the integration. Alright, so this is very important, but only for continuous random variable. Discrete one, it will have some value. Okay, but for continuous random variable, it is always equals to 0. Okay, so this is generally what about the continuous random variable. And then now we proceed to our main part, normal distribution. So normal distribution is a special type of continuous random variable. And it is the most important distribution in statistics. Alright, so actually it is true. There are a lot of questions in statistics. When we want to calculate the probability, we will use the normal most of the time. Okay, alright, so if let's say you are planning to take statistics 2 in your next and the third semester, please make sure that you are dealing very well with this chapter, because for statistics 2, most of the chapters, they are still talking about normal distribution. If let's say you don't know how to use the table, you don't know the concept, and you feel very blur on this chapter, better you don't take stats 2. Okay, all right. So why is it very important? Okay, so because for some discrete like binomial or maybe Poisson you're going to learn it in stats 2 also. Right, you can actually change it become normal distribution to get the probability. But of course, I must follow some certain condition. I will tell you the certain condition later when you're going to learn it. Right? Okay, so now let's have a look for some example that might be modeled by normal distribution. So you see the volume of fruit juice, the time taken, the mass, the height, diameter is length, right? And then also the time taken. So all this usually can be modeled as a binomial distribution. Okay, so for the distribution, once you know that it is normal distributed, then you usually will be given the mean and variance. Alright, so when you know that it is normal distribution already, then please write it out in this particular symbol. So X is normally distributed, N is normal. Right, so the first value must be the mean. The second value must be the variance. You cannot exchange the sequence here, it must follow exactly. Alright, the first value is always the mean, the second value is always the variance. Alright, so here they explain to you what are all the symbols mean. Generally, you learn all this before, okay? But I just want to take note that you have to write it up once you know that it is normal distribution. Okay, so there are some properties of the normal distribution that you need to know. First, it is L-shaped. So usually for a normal curve, it will look something like this. Secondly, it is symmetry at U. So that means the mu is in the center, the highest point here. When you take it and label it, it will be the value of mu, the mean. Right, so it is symmetrical and mean. That means our left, right, area, left, right should be the same. They are symmetrical to each other. So mean, median, and mode are coincide. That means all the three value mean, mode, and median are at the same line here. And then the total area under the graph is 1. Okay, so I think this one you need to remember it because it is a very important concept. Symmetry is also very important. Symmetry and also total area under the graph is 1. So that means the whole area under my normal graph, it is equals to 1. Okay, that means the total probability can be also equals to 1, right? Your total probability cannot be more than 1. 1 month, correct or not? Yeah? Alright, so now, you need to take note on this. Changes in the mean or position of the curve. Changes in standard deviation alter the spread of the curve about the mean. Okay, so what does it mean? Okay, if I say the mean value is different, but the variance is the same, what will happen to your graph? I think it is quite worth for us to discuss. Right? So you can have a look here. Okay, for this example, I'm having two distribution here, first one and second one. Alright, so if let's say you look at the value, the difference is the mean, but the variance are the same. Okay, so the mean means that you are moving your graph either left or right. So that means this value is a 13. Then this value is a 20. But okay, so this is the difference of the mean. But if you look at the shape, the height, the width, the width of the graph, generally they are the same. Why? Because the value of variance are the same. How high is the graph? Okay, how wide is the graph? It depends on the variance. Okay, then the mean decide the position. Yeah, left and right. Okay. Then now, how about if let's say we look at the second figure here? Okay, if let's say for the second figure, again, if you look at the graph here, okay, so the difference is in the variance. The mean are the same, both are 15. So if you look at the center of the graph, the higher graph, okay, so you can see that it is at 15. The lower graph also the same, the mean is also at 15. Okay, but the changes of variance will actually change the shape of the graph. It's still bell shape generally, but the spreadness of the graph. Okay, so usually it's like that. If let's say your value of variance is small, okay, then it usually thin. and tall. But if your variance value is a big one, then usually it will be short and flat. Okay, so look at x1. So x1, your graph ends at here, right? Okay, and then taller, correct or not? So generally for graph number 1, we should say it as tall and thinner. But if you compare with the x number 2, the graph number 2, you'll see that it is fatter compared to x1. Can see that? Because the spread is wider. Therefore, it becomes fatter. And if it becomes fatter, right, then you will see the height is short, not so high. So compared to x1, you will see that it is shorter and also fatter. Okay, so this is how the mean and also the variance affect our graph. Okay, all right. Okay, then now let's continue further. Okay, so this part actually is not so important, but I just want to let you know that to draw a very a better normal graph, you need to know this one, the part number 3. Approximately 99.9% of the value lies within plus minus 3 sigma of the mean. So that means if let's say you're having a good normal curve, okay, you will see that the last value here at the end, both end, generally is more or less like mu plus 3 sigma and also mu minus 3 sigma. Okay, maybe I put a star here. Okay, so usually I will tell students, try to remember this because it will be very useful if you want to draw a very accurate normal curve. Alright, so the mu minus 3 sigma and also mu plus 3 sigma is very, very important. Okay, so by combining all the concepts that we learned on top, I would like you to draw. Okay, try to combine all the things that you already learned just now. Maybe you can discuss 1 or 2 examples here, which is not in the note. Okay, let's say I give you one distribution. X is normally distributed. Let's say I'm having 15, variance 4, and then I'm having Y. So let's say Y, I have the mean 20, and the variance is also 4. And I want to sketch these two graphs in the same diagram. How can I sketch it? Okay, so usually I will tell students like that. Okay, so first, if you want to draw a very nice one, okay, with a scale, then what you need to do is that first value, try to find out mu minus sigma. So sigma is standard deviation. So this standard deviation is a 2. Variance is 4. So standard deviation is a 2. Okay, so you are taking 15 minus 3 times 2. So you should have a 9. Okay, and then mu plus 3 sigma, what do you get? 15 plus 3 times 2, 3 sigma. Okay, mu plus 3 sigma, mu minus 3 sigma. So when you plus them together, you're having 21. Okay, so the same thing happened for the Y. Okay, so if I say mu minus 3 sigma, so again, you're having 20 minus 3 times 2. So you're having 14. And then mu plus 3 sigma, what do you have? 20 plus 3 times 2. So you should have 26. Okay, so all this really tells you that roughly where, when you want to draw these two graphs on the same scale, then you need to know roughly where your graph starts and where your graph ends. Okay, so my graph starts at around 9 and at around 26. Okay, so maybe I can just put my scale like that. Okay, I want to draw these two graphs in the same scale. So maybe I will have a scale first. Okay, let's say this is 9, 9, 10, 11. Okay, so you try to complete the scale. Oops, 23, 24, 25, 26. Okay, so let's say for the first graph, I'm having mean is 15. So the mean is 15. All right, and then 9. And also end at 21. Okay, so you can draw a very nice bell-shaped curve like this. How tall you want it to be, it doesn't matter. Right? So as long as later when you want to draw the Y, the height is the same, and also the straightness is almost the same, then okay already. Okay, so this is my X. Okay, and then if I want to sketch the Y, so the mean is 20, so 20 is here lah. So before you sketch it, you just make sure that the height that you have is more or less the same, like the X. Okay, because they should have the same height, same straightness. Alright, so okay, then now you look at this, the ending value is 14, so 14 is here. Then you're having 26, so 26 is here. Therefore, if you put the height almost the same, then when you try to sketch the graph, the shape and everything should be almost the same. Alright, so we are actually using the mu minus 3 sigma and also mu plus 3 sigma as the as a reference for us to draw the normal graph. So only if when they want you to draw it and compare like that, then you can use this formula. If let's say when you want to just use the graph to solve the normal type of question, then no need to draw until so detailed. Understand what I say or not? But when they want you to compare two graphs and so on, then you have to do it like that. Okay? Can Alright, so how about we change another question? Okay, so I hope that you have some time to copy this already. Okay, so if no problem, then I would like to change my value here. Okay, how about if let's say I want to sketch two graphs that have the same mean but different variance. Okay, so as an example, maybe for my X now, I want to define it as 18, and then maybe the variance is a 4, and then for Y, the mean is still 18, but I would like to make it as a 9. I think 9 will be good enough lah. Okay, so let's say I'm having 18.4 and 18.9. So the variance are different, right? So the same thing happened here. You take 18 minus 3 times 2. What do you get? And then 18 plus 3 times 2. So this one you should have 12, is it? Then this one you should have 24. Okay, then how about for the Y? 18 minus 3 times 3. You get a 9. And then 18 plus 3 times 3. You should have 27. Okay, alright, so now start to sketch it. Okay, so for X and Y, because X is, I can say is thinner, not so fat. Y is fatter, right? 9 to 27 is fatter. So 12 to 24 is thinner. Therefore, this graph should be taller. Okay, so maybe taller, I draw it slightly taller. Okay, so I'm having 18 is the mean. Okay, so 12 maybe is here, 24 is here. So when you want to sketch it, it is a taller graph. So again, try to still make it as a nice bell shape as possible. So this is your X. What about Y? Okay, so Y should be shorter. So how short is it? Never mind. As long as it is shorter than X. So the limit is 9 and also 27. Okay, so if you try to sketch it out again, so you see that the straightness is wider. Okay, so this is the Y. Right, so this is how you actually try to sketch a complete normal graph. Let's say they want you to compare the difference between the mean and also the difference between the variance. So this is how we do it. Alright, so I hope that you can remember this technique. Okay, I don't know whether they will ask you this in the exam or not, but I remember there's one question asked before. Right, okay, so just make sure that you know how to draw this kind of graph properly. Okay, so the next part, we are going to discuss about how to use the normal distribution table in detail before we can go into the application questions. Alright, okay, so for this video, we are going to stop it here for this part for now. Alright,